Rahim. So let's start once again a quick revision of how to find square root of this. Okay, so this is 35 minus 2 iota. So how to find square root of this? So have a look now. So step number one, all of you know, we assume that square root of this is, let's say, is equals to x plus iota y, and because when you take the root of this, you get a plus and minus automatically outside. Like a root of 49, you will get plus and minus 7. So same story is this. Now after this, squaring both side, when you're squaring both side, square of left hand side, I will get 35 minus 12 iota, and squaring of right side, square of plus and minus will give you plus, and I will get this kind of format. Okay, after this I will expand right hand side specially, and I will squaring of first term 2 into first term second term plus second term square. So this x will come in first two brackets and iota y will go in second two brackets. So x iota y and iota y. So 35 minus 12 iota, square of x, and 2xy iota. And you know it very well, square of iota and square of y. This is minus 1 and y square. So short story, I get negative y square from here. So I get negative y square. Now I will compare real part and complex part. So when I compare real part is 35 and this x square and minus y square. Real part is means is no I is there, no iota is there. Is equation number one. And this is called iota coefficient. And here this whole thing is iota coefficient. Look, iota and iota. So you know it, last class we have done this kind of thing. 2xy equal to negative 12. I repeat, this whole thing equal to negative 12. I will divide either 2x down or 2y down. So I will make a y subject. When 2 will go down, I get negative 6 upon y. This equation, sorry, negative 6 upon x. X equation number 2. This y value I'm going to plug in here. So when I plug in it here, it will look like this. Okay, and square of this, and yeah, so 36 over x square equal to 35. So LCM, I will take x square, I get x4 minus 36 equal to 35. Cross multiply, I get this kind of form. 36 equal to 35, x to power 2. Bring on the left hand side, rearrange, I get this kind of form. Okay, wait a minute. This is a correct. Okay, 36 into 136, and factorization, we can apply factorization, or you can apply quadratic formula. So this gives us negative 35. So x to power 4, negative 36 x square, and plus 1 x square, negative 36 equal to 0. I have taken x square common, I get this kind of thing. Here 1 common, I get x square minus 36. So after this factorization, I got this kind of form. I got two answers. One is coming is 36, and second is I'm getting is negative 1. If I take a root of this side, both, if I take a root of this, I get a plus and minus 6. But if I take a root of this, I get a plus and minus of minus 1, which is give us what? Iota. And whenever this kind of question, iota complex numbers come, we will ignore. Although I can take both equations, but this I'll ignore, and this I'll take only. This I take only, I will take two and answers here, positive x, and here I take negative x. And this equation I will use again, y is equals to minus 6 upon x. Y is equal to minus 6 upon x. So this x will go down, and I get y equal to minus 1. And this minus 6 goes down, and I get here y is equals to plus 1. And formula is x plus iota y. Look on the top. This was the question, outside plus and minus. So I think very clear. If I plug in this 6 here, I get a 6, and minus 1 here, I get negative iota. This is my first answer. Same approach, if I copy this negative 6 here and 1 comes in the place of y. So negative 6 and plus iota. So this is my second answer. So alhamdulillah rabbil alameen. So I believe the point is very, very clear and question is completely over. And now today I'm going to teach something new. Let's start that one. Yes, student, now today my plan is to discuss with you argument, modulus, and polar form, all three together. All three, inshallah. Okay, let's start. For example, there are some rules and regulations. So first of all, let's say I have a z equals to 3 plus 4 iota. Or I think better if I take such a number which is easy to solve. And wait a minute, let me plan for you. 3 and I think if I take iota 1 plus root 3 iota, this is a better approach. Okay, so let's try to solve this. What question he can ask you? Number one, he can ask you number one part, find a modulus. Number B, he can ask you argument. And number C can ask you polar form. And last form, I need to find out Z. Wait a minute, it is a root 3. So, okay, it is actually 60 degree. Yeah, 60 degree. So I talk about, let's say, power 4. So this I need to find extra. Okay, so let's work on it. Bismillah ar-Rahman ar-Rahim. Modulus. What is modulus? Okay, and I will do one more thing, an Argand diagram. So first of all, I say that Argand diagram. So Argand diagram. So job number one, make sure whenever modulus have no problem, but when I go for the argument as a teacher, I suggest you please do first Argand diagram and then you do it. So that is right. I'm going to make it. So all of you concentrate. So first of all, what is this? Is real component. This is complex part. You know it very well. And I discuss in lecture number 1. This is a real part. Okay. And this other one is what here is a complex part. And all of you know root 3 is 1.7321. Okay, approximately. So let's make it a value there. This is a 1, this is a 2, this is a 1, and this is approximately 2. Okay, so if I look at carefully, this is a 1, so it means I reach here. This is root 3, 1.7321, approximately here. So I make it a label here. This is a root 3. So this is a point I mark for Z. So this point is very clear. And this, and after this marking, and after that, I will join this with a straight line with the origin. That's it. And this is O, okay? And you can write this in bracket or not write, no problem. Don't write, no problem. So this is 1 stand for this one, and this after comma, this is called Y component. So this and this I will make it here what? Real axis. And here you mention what here? IMG, shortcut of writing imaginary axis. Okay, this whole thing is called Argand diagram. Okay, so I believe you got idea. Now I'm going to this is a rough idea, sketch. Okay, not accurate diagram, sketch only. So Argand diagram, I have done it. Now I'm going for modulus. What is the modulus definition? I'm writing parallelly with you. Okay, all these things. Star number 1. What is modulus definition? Modulus is shortest distance from origin. So there's a definition of a modulus. Okay, so if in this sense, if I ask you what is the modulus of this Z, so it means shortest distance from origin. And I believe you can see clearly this as a right angle triangle. You can sense from here. So this right angle triangle, I'm going to make it here. Okay, wait a minute. So this right angle triangle, and this gap is 1, and this gap is root 3, and this is actually, and we have a special sign of expressing. And what is special sign of expressing, which I'm going to do now? So A part, 2 lines across the complex number, 2 straight lines, vertical lines across, that is called modulus. And modulus is called short distance, you know it by Pythagoras theorem. and this is 1 square and root 3 square and root of that. This is called a Pythagoras theorem. So in short story, Pythagoras theorem itself is called a modulus. So 1 here, root 3 cancel, 3 plus 1, 4 is root 2. So this is called modulus. So first part, Alhamdulillahi Rabbil Alameen, finish. So this is a modulus. Modulus is over. So short story, what is definition of modulus? I mentioned here, shortest distance from the origin is called modulus. First part is done. Alhamdulillahi Rabbil Alameen. Now let's move on part number 2. So some rules and regulation for argument. So let's see the rule. What is the modulus? What is the argument definition? So argument is shortest angle with x-axis. With x-axis is a very important thing. I just tell you, many students do mistake here. Okay, I show you. For example, I give you 2 or 3 examples to understand. So let's say I have a 1 point here, 1 point here, 1 point here, and 1 point here. So if I join with this, this is called argument. And for this, this is argument. And for this is argument. Wrong. Why wrong, sir? Because the shortest is this one. So this is the shortest angle, and this is the longest angle. I will not take longest. And for this, the last one is arg. And you know, whenever we move anti-clockwise, angle always positive, and when we move clockwise, angle always negative. This is rule fix. So that is why whenever it means you learn one lesson starting from 0, ending at 180 positive, and from here going backward negative 180. So it means your arguments remains in the boundary limit of +1. Okay, I just mentioned here, hold on. So it means argument stay in the range of less than +180 and bigger than -180. It means I can go from here maximum, I cannot cross the boundary. And same approach, I can go from here, I cannot cross the boundary. So it means in both options, argument stay in this range. And I can show you some examples, inshallah. Get ready for the argument concept. And as a teacher, I suggest you, please, argument part, at least you make it. So this angle, this is theta. This is a theta. How to get this theta? As a common sense, use sohka to our opposite by adjacent. So I'm writing here tan theta, or I can say tan inverse, opposite by adjacent. And this is my answer. And I've got, okay, now here we have 2 choices. If he mentioned degree, to use degree, otherwise you can do radian also. So but you can use anyone, no issue at all. Sometimes he mentioned and sometimes he will not mention, but no problem. Okay, that is why you answer the mark scheme, and both answers are there. Okay, this is give you 60 degree. I write in degree just sake of your understanding. But do you think this argument? Yeah, this is correct answer, because if we look at carefully, there's a short angle, there's no problem at all. Okay, Alhamdulillahi Rabbil Alam. So I must write the word argument now. Argument and the bracket complex number. Which complex number? Z complex number. And what is answer? Why write degree? That's it. This is my answer. Don't stop it here. You have to mention this one. Okay. Sometimes you know what happened. Look, I show you. Look, I show you. If triangle is coming here and 60 degree answer. So theta is 60 degree, but argument not 60. Argument is 120. And I believe the argument, the point is very clear, and 120. So same approach, if the triangle is at this point here, 60 is here, for example. So theta is 60, but argument not 60. Argument is this one. So argument is what? Argument of Z become what? -120. How one negative? Because this is 180, 60 gone, 120, and negative is for direction only. So I believe the point is very, very clear. So sometime angle and argument same, but sometimes angle and argument not same. Short story, if we have in first quadrant, so angle and argument remain same. Otherwise, these values can be different from each other. Okay, modulus over, argument over. Let's talk about a polar form. So what is the polar form? Polar form is special format which we converted. Look, I'm going to show you polar form. Okay, polar form is a special format. And what is the format I write for you? So outside modulus, bracket open, then I always write cos of argument in the bracket plus a sign of argument in the bracket, and I must write iota. And hold on, iota you write before or after, no problem at all. I write iota here. So this is special format is called a polar form. So let's convert it polar form. So modulus, I got a 2, so I'm writing 2 outside, bracket open, and cos. And argument is 60 degree. I just write like this and leave it. and this is I iota sine time to 60, and that's it. This is my answer, and I will not do anything else. This is my final answer. And some student try to type in calculator. If you type in calculator this one and do multiply inside again, you will get this one. So no need to convert it. And if you multiply 2 inside and type in calculator again, you will get a √3. Okay, so no need to convert. It means if you convert back, it will give you your normal format. I hope so. This part is clear. And let's go for polar form is over. Let's talk about the Z4. How to find Z4? Actually, Z is what? Z is we have a 1 plus √3 iota. If I want to ask, if I want to find, okay, polar form, you know it very well. Polar form is this one. So I'm writing in polar form. So 2 cos of 60 plus iota sine 60. Okay, so for example, if I ask to find a take power 4 on the both side, so take power 4 of the both side, take power 4 of the both sides. So when I take power 4 of both sides, here I got a 4 and 2 to the power 4 and whole bracket also power 4. It's a very common sense, nothing hard to understand here. But now I'm applying a new property that is called DeMoivre's rule. DeMoivre's rule, okay? And hold on, I'll just show you. And okay, wait a minute. Okay. We have a special format here. Okay, let me write here. So DeMoivre's, MOVRIES, DeMoivre's rule. What DeMoivre rules say? This power will multiply with angles. That's it. This is the process of DeMoivre's. 2 to the power 4 is 16. Okay, this 4 multiplied with 60, I got 240, 6 4s are 24. So cos 240 and plus iota sine 240. This is DeMoivre's, is a scientist's name. And he said that whenever you want to take the highest power, so power will just multiply with angle, and that's it. So this is story which I explained to you. And if we type in calculator cos 240, it is giving us what here? This is giving us -1/2. And if you type sine 240, it is giving us what format? √3/2 negative format, -√3/2 and iota. This 16 multiply with both inside. And finally, I get what? -8 and -8 √3 iota. It means that power 4, alhamdulillah rabbil alameen, I got this format. I quickly revise the story and hold a minute, please. So I repeat once again what I said. Sometime we can say power 400. So how we can deal power 400? Okay, so power 400 will multiply with this, and after that, and even power 400 also come here, and then we simplify that our answer. If I ask you, please do it this one. For example, if I have this and power is 4, if I say use binomial formula and solve it, it is a very hard to do it. Very hard to do it with this one. Okay, so you have to be careful, and iota also there expand very carefully, very hard. Okay, lengthy process. But you saw how easily first I convert the polar form and then take the power 4 and get the answer. So I believe the point is very, very clear, and I'm going to assign a question to you, and all students get ready. And question I am going to give you here. Let me give a plan, and a plan is what? Same I will take. Okay, same I will take, copy, and I'm going to assign a job here and get ready. Okay, and I'm going to give a job here. Same story, just change the values. Okay, I change the values. Hold on. Okay, I change the numbers, but this time I want to give you. Hold on. Okay, so I'm going to give you let's say 2 iota and -2 iota. Okay, sorry, not 2 iota. First is without iota, second with iota. 2 plus 2 iota. So make sure, or I make it, let's change here. This is negative sign, better with negative sign. To make sure it is coming where? 2 and 2 negative. It's coming in a 4th quadrant. Okay, so make sure. So now please take your time and solve this question first completely yourself, and then inshallah I will solve this question completely myself. Yes, student, you took more than enough time. I'm starting. Bismillah ar-Rahman ar-Rahim. What is a complex number? It is a very, very clear. One positive and one negative. So it means it is coming 1 and 2 and 1 and 2. So this is a positive. It means two positive is here. It is a negative 2. It means negative 2 is here. So complex number is this Z complex number. And this is a short distance from here to there is called a modulus. Okay, wait a minute. I make it again. Okay, this is origin. So examiner can ask you modulus, and here right here real axis, and right here I am the shortcut writing imaginary axis. Okay, so now first part Argand diagram done. First part modulus. So modulus is very clear. Root of 2 square plus 2 square minus, you not are big trouble. You write or don't write, no problem. 4 plus 4 8, and 8 root is giving what? 2 root 2. So alhamdulillah rabbil alamin, done. Now I'll go for first part is done, A part is done. I write again. So this part is done. Now argument. For argument, I said before, I need a triangle to make it, and this is a theta, okay, and this is a 2 and this is 2. So how to get theta? B part. So tan inverse 2 by 2, and it's giving us 45 degree. But do you think this argument, this is the same this argument? No. So when I go clockwise, this is called argument, because I said definition of the argument is start from the positive x-axis always, and shortest angle. I cannot go from here to there, wrong. Okay, this is the only choice we have. And what is this? We can write argument is 45, but I will write negative 45. So I believe this point is very, very clear. So alhamdulillah rabbil alamin, 2 parts over. Part number 3, polar form. And polar form, you just know it. So I'm looking for what? Complex number 2 minus 2 iota is actually equal to modulus. I'm writing outside. Okay, 2 root 2, I'm writing outside in a bracket, cos argument and plus iota and sine of argument. And I believe this is nothing hard up till now. So polar form is done. Alhamdulillah rabbil alamin. Don't do and this with the signs remain same. Now let's talk about the power 4. How deal power 4? I will take power 4 of the both side. I think is clear approach. Even power 4 here, even power 4 on the top. Okay, so 2 minus 2 iota, here 2 root 2, here cos negative 45, and plus iota and sine negative 45. I believe is very, very clear. Okay, now if you type in calculator and very carefully, so this is outside 2 root 2. Okay, if you type in calculator and power 4, it gives you 64. So this is 64 outside, but cos this is a root 2 by 2, and you know it is a cos root 2 by 2, and this is giving us negative root 2 by 2 iota. I repeat again. Oh, sorry. DeMoivre's rule. So first of all, apply DeMoivre's rule. This 4 will multiply with angle, and I get what? Cos of, and 45 times to 4, it gives us negative 180. And same story here. I get a sine of a negative 180 comes even here. Okay, and all people, you know it. When you go from here to there, okay, at this line, always cos is a positive one, negative 1, but sine is 0. So that is why this is giving us what? This is giving us negative 1. Even I go this way because negative 180. So this is a negative 1 and this is 0. So ultimately I get answer what? Negative 64. It means 2 minus 2 iota to power 4 is 64, and question is completely over. And let's go for next plan. So let's start, student. A next level we have, whenever we have a 2 polar form, okay? 2 polar form. For example, this is a 1 polar form, you can see. For example, 1 polar form we have, 2nd polar form we have. So if I want to multiply those complex number, for example, 1 is I'm writing R1 cos, sorry, I have to write bracket open, cos theta 1 and plus iota sine theta 1. This is a 1 polar form question. 2nd polar form, I'm writing it here. So 2nd polar for the 2nd complex number, and R2 cos theta 2 and plus I sine theta 2. Okay, so when you have a 2 complex numbers, how we can continue? Okay, if I want to multiply them, or for example, first I want to take a power of z. So you know, just you have seen now, if I take a power 2, so what do you do it? we take the power 2 of R1, so power 2 of this, and when you take a power 2 of the whole complex number, so what I do always, you have seen just now in polar form in DeMoivre's rule, for example, power 2. So power 2 multiply with the angles. I believe you got my point. For example, this power is not 2, power is, let's say, 20. So here 20, here 20, here 20, and this 20 will multiply with angles. So I believe they got a point. And if you look at carefully here, so what is this same story? So look at here. If this is a complex number, this is called modulus, and this is called argument. I write modulus and argument. So that power n I need to take. So I will take the power of the modulus directly, but with the argument I will multiply. You see, you look at here, you look at here. So this 20 will multiply. So according to DeMoivre rule, okay. So it means you learn one lesson. Whenever we will take a power with the modulus, take a power with angle, with the argument, we just multiply. So for example, I have one example available, which is very good to understand. This is a complex number Z I have. He said take power 2. So what is the technique to do it? I will find out the modulus, which is a very clear. I got 2 root 2 modulus of this. Okay, and argument is very clear. Let me find directly. I will find directly. So 2 is here, 45 degree. So argument is we have a 45, or I call it 5 by 4. 45 degree, 5 by 4, same thing. You know it very well. So if I look for what for the z to power 2, what I will do, take square of this number. Look at here, you can see, take square of this number, and that power 2 will multiply with the argument. You see this 2 multiply with the argument. That's it. If I say no, I need power 3. So what I will do, take 3 power of this number. You can see here power 3 taken, and this 3 will multiply the argument. And Alhamdulillah Rabbil Alameen, you have seen that clear. So it means the modulus of the z cube is what is this, and argument of z cube, this by mistake square he wrote, it actually z cube. So the argument of z cube is 3 pi by 4, which is here. So short story, I think you understood very well. So as we have done just here, you can see we just done here. So what is the normal pattern? Normal pattern, if I take a power, so I will take power of modulus separate, and that power multiply with the angles, with the argument. Same story I applied here. So I think you got idea very well. But now I discuss with you next point. So one rule you got it. One rule you got it. First rule is here. I just show you what rule I talk about. So rule number 1 in a red box, I make it here. It means whenever I take a power will go on the modulus separate, and with angle it will multiply. That's it. But when you talk about next plan, so let's go for the next part. So one rule is clear. Second rule I talk about, whenever 2 complex numbers are there and they want to multiply. So when they multiply this one, what is the situation? Like Z1 into Z2 multiply. So what will happen with the argument? So argument will multiply simple and straight. R1 into R2, simple, okay? But what about the argument? So our argument will not multiply, will add. This is a rule. So rule is what? Whenever we have a 2 complex number, polar form multiply, okay? So argument will multiply directly, but the argument, modulus will multiply, but argument will add. So look at here. This is a modulus, comma, and argument is θ1 into θ2. So θ1 and plus θ2. I mean, they will add. So in the condition, they are multiplying. Look at their multiply. So multiply like a log property. You remember in log property, when 2 values are multiplying each other, we split them by putting a plus in the middle, if you remember. So same story, this multiply convert into plus sign. So same, this multiply convert into plus sign. So this is I want to show some example. Then you realize this situation. So let's see this question 2 question we have here. So in this concept, we have a z square available here and w square available here. Okay. So I'm going to show you z square. Where is z square? Z square is available here. Z square modulus is 8 and z square argument is pi by 2. And similarly, w square. W square is modulus is 4 and w square argument is 4 pi by 3. And if we want to multiply, hold on, I show you once again. Look, I put a box here. So you can see one box on the top, and this is a second box here. This is w square, and this is z square, and this is a w square. And if we want to multiply them, what will happen? So this 4 and 8 will become 32. See, 8 4s are 32. Repeat, modulus and modulus will multiply. an argument will plus. That's it. So I repeat again, even he mentioned how he put a cross multiply sign. So 4 and 8 will multiply, but argument will not multiply. Arguments will simply add up. So this property is very, very clear. And let's talk about the last property. There's a dividing criteria. So when two complex numbers we have given, let's say first complex number R1 is modulus and argument is theta 1. R2 is modulus of second complex number and theta is the argument here. So when we divide it, when you want to divide them, what happens? So naturally R1 up, R2 down, like dividing. But with the argument, we're never dividing, we'll subtract. Like after logarithm, if the two values are dividing, so how we expand it, look, I show you A by B, how we apply it, log of the first value minus log of the second value. So same story, this minus sign here. So let's talk about some example. Then you realize it, what is going on. For example, this is can you see W square and Z cube are dividing each other. So W square and Z cube dividing each other. But I tell you directly, the modulus of W square, I mean this, and modulus of Z cube, I mean this, will divide directly. But what about the argument? So argument of the whole number, is simply, you can say argument of W square minus argument of that. Hold on, I show you. Argument of W square minus argument of Z cube. So this is a whole story, and I'm going to show you. Let's start. First of all, let me show you W square and Z cube. W square and Z cube. Z cube is where? Hold on. Yeah, Z square. Look, I erase first of all. I erase the first part, and then I tell you the whole idea. So this is Z cube. Z cube is this one. I put in a box. This is Z cube answer. Okay. Where's W square? This is a W square answer. So let's discuss. Z cube is this, and W square is this. And I want to divide. And what is dividing criteria? W square up and Z cube down. W square up, Z cube down. What is dividing way? So W cube is square is this one, 4. And Z cube is this one. So this 4 up and this down. So this is my answer of a modulus part. If I want to take a modulus, so it becomes 4 for the 16, 104 root 2. This is a modulus of that. But what is the argument now? This is a modulus. What is argument of the whole thing? Look at now, W square over Z cube. And according to criteria, what is the technique? A technique you learned just now. According to criteria, argument of W square minus argument of Z cube. Okay, wait, please. W square argument is 4 pi by 3. And argument of Z cube is this one. So 3 pi by 4. Okay, if I type in calculator, let's type in calculator. So I got what? 3 for the 12 LCM and 4 for the 16 pi and 3 to the 9 pi. So if I check it carefully, I get 7 pi by 12. 7 pi by 12. And look at here. This is Alhamdulillahi Rabbil Alameen. You see, the argument is very clear after simply subtracting. So let's go with a summary of the topic. Summary of topic is what? Whenever we have a simple power is there. So power will go on modulus separated with argument multiply. And whenever there are two values are dividing, so simple dividing of the modulus, but argument will subtract. So I put a red box around the formula. And the product is on the top. The third rectangle is here. And this is a third box. So in case of multiplying, argument add. In case of dividing, argument subtract. Okay. And in case of single number, power will multiply with that. So I believe all rules are very clear. And now we can go for one example. Okay, I will make one example for you. And so wait a minute. So student, let's have a look example. The page number of textbook is the same 264. And question number 10, I put 4 arrows. There's a question number this question number, and this is okay. And last we have this one. So 4 questions you will try. First you will try, then I will do this question myself. And luckily, there are 2 complex numbers given. One is Z complex number, one is W complex number. Okay. So when you think about Z power 8, so I will concentrate on these things only. Okay. And when you talk about Z and W together, so I will just, you know it very well what to do. And formulas are very clear. So in case of multiply, like Z and W multiply, So what I will do, modulus of both will multiply. And argument of both, argument of z plus argument of w will add up. This in case of multiplying. If they are dividing, you know it very well. Modulus of z, modulus of w divide, and argument would what happen? Argument of z minus argument of w. I believe you got a point because due to dividing. So all people try this question, and the power is very clear, not a hard job. And modulus will power 8. So power 8 of modulus will come directly on the top like this. But argument, if I find z8 argument, you know what happens, students? 8 will multiply with the argument. 8 times 2 argument. I think you know it very well. First, you try this question, then I'll do this question myself. So take your time, please. Yes, students, so I'm going to do this question now. Bismillah ar-Rahman ar-Rahim. First of all, D part, z to power 8. D part. So z to power 8. What z is, okay, because he asking the modulus and argument. So what is z? Because z modulus is 3. So if I'm looking for z8 modulus, naturally, I will take the power of 3. That's it. Okay. And because basically the formula is same, so I will take the power of that. And 3 to power 8 is giving us what? 6561. So modulus of z to power 8, I got it. Simple. What is the modulus? We take the power of that. And now I talk about argument of z to power 8. So what is basic criteria? Whenever given this one, so apply DeMoivre rule. DeMoivre is this 8 will multiply with the argument of that. And argument of z is pi by 4. So 8 times 2 pi by 4. And I get, alhamdulillah, Rabbil Alameen, 2 pi. So that is first part is done. D part is over. D part is over. So D part is over. Let's talk about the E part now. E part, Z and W multiplying. How do E part? So Z and W multiply. If I want to find the modulus of this one, as he said before, so what I will do, simple modulus of 3, Z and W will multiply, nothing change. 3 into 2, I get 6. But if he asks, no, give me the argument of both product. So basically definition, what? Whenever multiplying, we can simply add argument of Z plus argument of W. Simple and straight. And this pi by 4 and pi by 6. So I will just add, and I think you got a point clear. So LCM is it is a pi by, so 1 divided by 4 and plus 1 divided by 6. So it's coming 5 pi by 12. I'm writing directly. So 5 pi by 12. Clear? So I believe these two parts are clear. D part and E part is clear. And now I'm going to show you F part. F part is what here? He said this one. So modulus of Z and W square modulus. So common sense, Z modulus is 3. I will take 3. And Z square, W square means I will take square of W, the square of 2. That's it. So 4 is a 12. Alhamdulillah Rabbil Alameen. Clear. If I ask you what to find argument of Z time to W square, so what is the planning here? So argument of Z I will write here plus argument of W square I need here. Argument of Z is what, student? Z is a pi by 4. I need pi by 4 from here. But you know, DeMoivre's rule take 2 power of that. So this 2 will multiply with this pi by 6. So 2 multiply. So 2 times 2 pi by 6. And I believe it's very clear, 1 by 4 and plus 2 divided by 6. My answer is coming with me 7 pi by 12. So this is argument of Z times 2 W square. I believe you understood well. Nothing hard. Alhamdulillah Rabbil Alameen. Last part is division criteria, and that you're familiar. Z, actually, what is the story? Z up and W down. Z up and W down. So if I say Z up and W down, so simple modulus of Z is 3 and W is 2. So 3 by 2. So this is not a hard job. Done. Alhamdulillah Rabbil Alameen. But when I talk about the argument of Z by W. So what is the rule? I will say argument of Z minus argument of W, because division criteria. So Z and W, let's see Z and W. Z is argument is this and W is this. So pi by 4 minus pi by 6. pi by 4 minus pi by 6. Pi by 4 minus pi by 6. And finally, 1 by 4, 1 divided by 4 minus 1 divided by 6. It is giving us pi by 12. So Alhamdulillah Rabbil Alameen. And I believe the concept of the topic is very, very clear. How to deal this kind of question. So Alhamdulillah Rabbil Alameen. And I think this concept is clear. So student, this class is over and concept of the whole is clear. And as a teacher, I suggest you, please, if you do these 2 questions, it's good for practice. Question number 9, okay, this multiplying, so you know it very well what to do. Modulus will multiply outside, and argument pi by 6 and pi by 3 will add. Okay, what about this Z1, Z2, Z3? So all 3 modulus will multiply. Alhamdulillah, easy. But how to find out the modular argument? So this argument plus this argument plus this argument. But he said convert into modulus argument form. It is also called polar form. Let me help you. Modulus argument form is also called polar form because he given us 3 polar form on the top. And I believe you got my point. So you have to convert into polar form. And division criteria, you know, the modulus simple divide, but argument subtract. And what about this square? Power 2 of modulus directly, but the argument power 2 multiply with the argument. I think you got my point. So this question number 9 and 10 is homework. Inshallah, next class we'll go for our loci part, which is a very, very important. See you next class. Assalamu alaikum wa rahmatullahi wa barakatuh.